Good morning to all the students. So, in our last class, we have studied the general features of the matter or the general properties of the matter. So, today we are going to study about the uh, different topic about matters. That in this matter, we are finding about minerals. So, before going to the main topic, so first we should know what is mineral. So, if we define minerals, or if we say simply the what's the mineral is, minerals are the pure substance. They are the mixed compound, pure substance, but mixed compounds of two or more metals or single metals or elements. So we can say that minerals are the compound that are formed or the substance that are formed by the combinations of two or more elements or two or more metals or matters. Okay. Then after that, if we comes to the next word, that is called as the ores. So what is ore? Ore is similar to the minerals, but the difference is that the ores contain large amounts of metal so that we can get more metals when we purify. So for industrial use or industrial extractions of metals, ore is being used. So ores are those compounds that are formed by the combinations of two or more materials which contains a large amounts of metal. So that can be used for industrial extractions. Like for example, there are lots of examples of iron ore. So hematite, magnetite. So it contains what? Iron oxides. So in this ore, iron is combined with the oxygens and the amount of iron is large, so that we can easily extract for the industry, as well as it is profitable because it contains large amount of metal. So these are the means, that is the ores and minerals. Now comes to the next word, that is the we will get is metallurgy. So what is metallurgy? Metallurgy, that is, metallurgy is the process of extractions of metals from the ores. Simply, extractions of metal from ores. Okay, means, so what we come to know that minerals are the compound or the means substance that contain more means pure metals or the elements or matters. Okay, ores are also similar to the minerals. It contains large amount of metals, so that it will be profitable for the industry to extract from it. Then what is metallurgy? It is the process of extractions of metals from the ore. So extractions means to take out. Okay, how it is been done? There are the three major process. Okay, three major process. The first process is concentration. Okay, the first process is concentration, in which what we are doing, we are means removing all the impurities from the ores as far as possible. Okay, so concentration means we are concentrating those metals which we are going to extract, or we are separating the impurities from that metal. That is the concentrations. Then the next one is the we call as the that smelting. Next process is the smelting. Okay, smelting means the chemicals which are present in the means ores, like for example irons with oxygen. If we see irons with oxygen, so we have to remove this oxygen. Okay, we are removing this oxygen. Now what is the difference between concentrations and smelting? Concentrations means we are differentiating the impurities like dust particles and other particles that are present in the ores. Likewise the other parts. Okay, but smelting means we are separating some of the chemicals which are associated with that metals, which are associatively occurs with that metal. That process is called smelting. Then the third one is purifying. The third process is called purifying. So we are not need to study all the process in detail, but we should build up a concept that metallurgy is the process of separations of metal from the ores. What? That is the separations of metal from the ores. Then this have a sub process called one is the concentrations. So concentration in which we are means concentrating or we are removing the dust particles or the other materials that can be removed easily, or the physical materials that can be easily removed like sand, dust, etc. So that is called as the concentration. Smelting means we are removing the chemicals that are attached with the metals, like I have given the example of iron oxide. So we are removing the oxides from the iron so that we can get a pure iron. Then purifying means the remaining chemicals or the substance or vapors, water, etc. which are still remains in the metals are being purified. So after that we will get the pure metal. So these are the some of the topic we have to remember in short. Now comes to the main metals. Today we are going to study about the iron. So we all know or we all use iron in our daily life. In our daily life we are using iron. So what color does the pure iron have? What types of color the pure iron have? Mostly it is grey in color. It is grey in color. So if we talk about the iron, mostly there are two types of iron. Okay, cast iron and what? Wrought iron. Okay, it is not necessary for you, but still we should know there are cast iron and wrought iron. Cast iron we can take, that is cast iron भनेको जस्तो हामीले कराई बनाउँछ कालो कराई हैन, जसमा सेलरोटीहरु बनाइन्छ, they are the cast iron. When we heat it is break down. So cast iron and wrought iron is the pure types of iron, okay, which can be bent and so on. So cast iron and wrought iron, what is the difference between them? The difference is that cast iron contains large amount of carbon or associates with large amount of carbon, but iron or the wrought iron contains less amount of carbon, that is 1 to 2% of the carbon content. So we come to another parts, we come to know that iron is means used in our daily life. It is mostly two types, and steel is also made from the iron, but it is of two types. One is the cast iron and the another one is the wrought iron. Cast iron contains large amount of carbon, whereas wrought iron contains less amount of carbon. Now comes to the next part, that is the properties of iron or the positions of iron in the periodic table. What is the atomic number of iron? What do you think? What is the atomic number of the iron? Atomic number, it is 26. Okay, the atomic number of the iron is how much? That is 26, and the atomic mass or the weight is 56. Okay, so if we see in the periodic table, where it lies, 26 and 56, atomic number 26, and periodic table how much, that is 50, atomic weight, that is 56. 26 means what, that is 288. How much? 10, 18. How much remain? It is another 18, 8. So it falls on 8 group. Okay, it falls on 8 group. That may be 4s2. Last. So how it comes, you have to study that one. Okay, you have to study, because we have already studied in periodic table how it is been made. Now the next things. So it falls on which group? It falls on 8 group. Then which period? K, L, M, M. Which period? It is on the 4th period. It is on the 4th period. That is 4th period. It lies on 4th period and 8th group. Okay, 4th period and 8th group. So which block of this one is S block, this one is P block, and this one is D block. So these are what? Iron is D block elements. Iron is D block element. So what we come to know still now about the iron? In pure form they are grey in color. Number 1. In pure form they are grey in color. Number 2, there are 2 types of iron, cast iron and worth iron. Cast iron contain large amount of carbon, and worth iron contain little amount of carbon. Okay, little amount of carbon. Cast iron contain large amount of carbon. Then the next thing what we come to know, that the atomic number of iron is 26 and atomic mass is 56. Then the next things we come to know, that in periodic table the positions of the iron is in 8 group, 4 block or the period. 4th period 8 group. Okay, this is the 4th period 8, 4th row and 8 group. Understand? Then the next thing is that it is also called as D block element. Why it is also called as D block element? Because the positions of iron in the periodic table is in what? D block. Okay, the positions of iron in the periodic table is in D block. That's why it is also called as D block elements. And another word that is being used for the iron is what? That is these elements are called as what? These elements are called as transitional elements. Okay, these elements are called as transitional elements. Therefore, this metal is called as transitional metals. So in periodic table, these are called as what? Transitional metal. Then here another one is inner transitional metals. This one. So this is transitional metal. This one is inner transitional metal. Therefore, iron is also called as the what? That is the transitional metal. Okay. So these are the positions of metals in our periodic tables. Let us come to the next one, is the general properties. So general properties of the metal or the iron. What are the general properties? The first one what I said it is what? It is grey in color in pure form. Grey in color in pure form. Understand that one. You may find brown in color when it has been roast, because presence of oxygens make it brown or red in color, means brown color. Then the next thing, properties. They are solid and hard in structure as the general properties of the metal, and they are shining grey metals. We are already said the properties of the metal is shining grey metal. Then if we see the melting point, I already said you that it means it will be melt when you increase the heat up to 1600 degrees Celsius or above. Why? Why? Because the melting point of the iron is 1535 degrees Celsius. That means 1535 degrees Celsius is the melting point. So before 1535 degrees Celsius, the irons will remain as solid form. After the heat is been increased above this one, then it start to melt or it start to become a liquid form. Okay. Then the boiling point. Boiling point means evaporations, vaporize. That will be vaporized, or iron will be vaporized when you heat the iron above 2500 degrees Celsius. That means 2500 degrees Celsius. If you go above the temperature of 2500 degrees Celsius, then only it will boil or vaporize. Otherwise, it will presence here to here, it will presence as a liquid form. Then it is not found in earth in free form, because they are highly reactive. Okay, they are highly reactive, and therefore they will always remain attached with another compound or elements. They will always remain in combined form. They will not exist independently. Like for example, we can take, there are ores of iron. Let us take the example of ores of iron. Hematites is the ore of iron from which iron is being extracted in industry. They remain combined with what? Oxide. Fe2O3 is the hematite. So they will remain combined with the what? Oxygen. Likewise, magnetite. Magnetite is the another ore of iron which is also present in combines with oxygen. Okay, in combines with. I forgot to say that iron, the symbol of iron is Fe. Symbol of iron is Fe, and it has a variable valency of 2 and 3. Okay, it has a variable valency of 2 and 3. So here the valency of iron is 3 farad. Then here the valency of iron is 2. Okay. So the iron carbonate. So here iron carbonate is the another ores of iron. It remain combined with carbonate. So here iron presence in earth in combined with oxygen. Here it is presence in combined with carbon. And lemurite is combined with what? Oxygens and water, aqueous. Okay, water. Then it also remain combined with what? Copper and sulfur. So what I want to tell you that irons are not finding in the pure stage or independently in nature. It will remain in nature as a combined state. That is the main and another properties of the iron. Then if we see the earth crust, then in earth crust 6.2% of the earth crust is made up of iron. What I say, that is The earth crust or the earth crust, the main earth crust is made up of iron and it contains 6.2% of the iron. Means among the different metals, iron is 6.2% in the earth crust. Then the another one, it is also a ferromagnetic substance. Okay, these are ferromagnetic substance, means they have a magnetic property. We can make it magnets, but it loses its property when the temperature is increased to 700 degrees, 770 degrees Celsius or above 700 degrees Celsius. The ferromagnetic properties of the iron will be lost if we heat more than 70 degrees Celsius. That is the another properties of the magnet, metals. Then the next one is they are malleable and ductile. So we have already studied about the malleable and ductile. What is the meaning of malleable? Malleable and ductile. Malleable means what? That is, it can be beat into a thin plate from the thick one without breaking. Like iron sheet, we can make it, okay, by iron block. Then the next one is ductile, means the iron can be made into a thin thread-like structure. So we are getting iron rod for the building purpose that are being made from the what? From the iron. So these are the physical properties of the iron. So the chemical properties and the use we will complete tomorrow. The main important for your exam is the ores of iron and its some of its property. So among the ores, the highest used ore or contain large amount of iron is hematite and magnetites are generally used for the productions of iron. So you should remember that hematites and magnetites are the two mostly economic and largely used ores for the productions of iron. So these are the ores. You should by heart this one. In exam, the example may be asked that copper pyrite is the ores of copper, sulfur, or iron or aluminium. So in this way you should know that one. And the another property, that is the ferromagnetic substance, is one of the different properties of iron. You should remember that one also. So thank you to all of you for watching this video.